Yesterday I shared with you a video which is related to logic operation. We learned the basic logic and exclusive logic. So today I will touch also on the logic operation. As I mentioned, it is because I want all of you to get extra information, extra reference, because this one is for your module, and I hope that if I give you extra videos and I keep repeating similar info and also sometimes extra info, so you will increase your own understanding, so you can also memory all the informations easier. So in this video I will touch on logic operation also, and until up to end of your module 1, because as I mentioned in this in last previous class, that I'm going to finish this first module, and then after that we will focus to second module, and every day I will upload a new video for you, whether it is related to module 1 or maybe the new module. I just want to add as many as information for you, so just please make sure you keep looking your e-learning, and then I will also upload extra notes in your e-learning site. So here about logic operation, I hope all of you already have the basic understanding on this and still remember what we learned yesterday. So first of all, you learned yesterday also in previous video about the basic logic function. One of that is AND gate. So the behavior of AND gate is true only if all input conditions are true, or you can set it, the output will be only get 1 or on or high if, let's say, all the input is 1 or high or on. So you can see over here, this is the symbols where you have 4 input. Like previous video, I already mentioned that you can have multiples and more input for your AND gate as long as the minimum input is 2. So you can have more than 2 also, but for the output, of course, it will be only 1 over here. This is the output, and then this is the input. Next, about get all. So the behavior is you can only get true or 1 or high output if 1 or more input condition is true or 1 or on or high. So in this slide is represent as true. True is similar also to 1 or high, or even also it is on. So depend. So you can see over here also you have 4 input, and this one you have 1 output. And the next gate going to look back is on NOT gate. So the behavior is, it is like a inverter, and everything will be opposite to the output. So if let's say you give the input high or true, so it will be low or also false for the output, and etc. So you can see you can have these symbols and these symbols, but normally we use this one as not get. But you can see previous video also, which is related to, I think there is over here, let me see, this one. You can see the symbols is representing like this. So it's depend, but as long as you know basically how the not get look like, go back to our main slide. Where is it? That too long. Okay, right here. So you can see that basically the knot is when you having the circles over there. Okay, is it clear? Because I think you already go through a previous video, and now I think you already understand and about the behavior and also the truth table. So for the logic gate not, you can see if let's say the input is high, so the output will be low or zero as the output, and then if the input is low or zero, you will be get the high or one as the output. So it is the inverse operations. And this is the truth table. You can see not get, you have only one input and also one output, one input and one output. And this is the truth tables of not get. Last video also you already look into it, so now you look also again on this truth table. So I hope you already memorize and understand fully. So this is just a sample on IC 7404. Inside this IC you have the get not get. So it is a functions of 6 inverter. Over here you have 1 2 3 4 5 6 6 inverter, or we call it as not get inside the IC. So this is just example how it look like basically in the 7404 IC. Already also look into it, which is this one is logic gate N. Yesterday you already looked into it. Okay, for this gate you will look into AND gate, which is just last video you already looked into. You have 4 possibility of input because you have 2 input over here, and the most important is you will have only one output. If let's say the input is high, both input or all input, so you need to have all input as high or 1 or on, you will get high or on or 1 as the output. For the rest you will get as a 0 or low. So here you have the examples of IC 7408. You can see that you have 4 AND gate. 1 2 3 4. So you have 4 AND gate inside IC 1408. So this is just an example also how basically the IC look like, which is it included the AND gate. So next you're going to look into the OR, logic OR, which is this is the truth tables, and last video also you already learned on that. And you will get all output as 1 or high if you get at least 1 or high for the input. So is it clear? I think last video also already explained clearly. So now I hope that you will remember it and understand it fully. And this is another example. If you're having the OR gate, you can have it inside 7432 IC, which is also have 4 for the OR gate, and the input is all 2. So it is how it look like. And we can summarize it, our N, and then O, and our NOT gate. So how about others, which is you already also learned about buffer. Over here you will get the input, the output similar to the input, but for the NO gate you have over here NOT. I think in last previous note you also already look into it, which is exclusive gate. You have NAND gate and also OR gate, which is the meaning of NOT, and you have AND gate. And I also already give you the example how it's look like. Basically you have AND gate, and you will have also the NOT gate. And for the NO gate, it's look like this. So I think you still remember on the last video. And on the XO, you can have a look into it after thing, because this is the special gate that I mentioned in the previous video. So I will touch it and focus it in different video, and I focus it only the exclusive OR and exclusive NO. How it's going to summarize over here, which is you have these operations, and then you have it as a exclusive NO gate. You have 2 input and also 1 output. So what is look like, this is the truth tables. So later on I will give you an example of this, which is you have basically over here the exclusive or, and then you have the gate NOT. This is how the equivalence gate circuit or for the exclusive NOT gate. So later on I will focus it on next video, just to focus on those gates. So next is on our logic function. I will touch it a little bit about logic function. Logic function, which is on the overview only. So overview of logic functions, what we're going to learn inside here. So basically, basic logic functions, any digital system has one or more of the following function. You can go through on this, which is these functions are built from basic gate. So that's why I want you to have the full knowledge and understanding on basic gate, because if you don't have basic, you cannot understand, or it's quite hard for you to move to another functions which is more complex. So you can see over here the basic function that available, which is comparison functions, arithmetic function, conversion functions, encoding function, decoding function, data selection function, data storage functions, and counting function. So this is a list of functions that available, which is come from the basic get. So all these functions was including, let's say, no get, and then x not get, and then or get, or even net and get. So it is combinations of several basic gets that you already learned. So this is the examples of one function, which is comparison functions. What is the comparison functions? Is there is basic magnitude comparator. So over here you can see that there is two binary numbers, which is a and b over here, and then the comparator, which is the output. So for the output, you have the a more than b, a equal to b, and another one is a less than b. So it's become as the output. So if let's say the example, you have the binary code for 2 as the input for a, and the binary code for 5 for the input b. So what is going to have, which is a is less than b, because you notice that of course 5 is greater than 2, 5 is greater than 2, which is 2 is less than b. So as indicated by the high output for this output only, because this is the true answer. So this is how it functions. If let's say you have the input, your comparator will check which one is the correct one. So if the correct one, so it will be high as the true. So that's why I always mention you can have on, which is similar to 1, or also high, or even sometimes you can also call it as true. While for the low, which is off, basically sometimes it's called as off, and then the value is normally 0, and then we call it as low, and it is false. So please remember this, because sometimes in question it mentions false, let's say, so you quite confused. False is 1 or 0. So this is two basic information that you need to know. On equal to 1 or equal to high, and also equal to true. Sometimes in the test and also in the final exam, different lecturer create the question, so it's depend on them which words that they want to use. So just make sure that you understand about high and low, true or false, 1 and 0, on and off. So as long as you understand this, you can have basically understand the question itself. So next examples of function is on the arithmetic function. You can have, because arithmetic is more like mathematics also, you will be have the add functions, subtractor, multiplier, and also divisions functions of arithmetic functions. So first examples in on add, you have two input, and this one is the carry in, similar to the, if let's say you have the basic mathematics, you also can have the carry in, which is input sometimes. And if you can see over here, you have two binary numbers, a and b, and then the sum is equals to output. So the examples is given over here. This is the diagram of symbols on the arithmetic functions for add functions. So for the examples, we have the binary code of 3 at A, and then binary code of 9 for B. So you have basically have 3 plus 9, and then you get 12. So this is for this sum over here. And you can see that you have C input. So normally you have another input extra, which is 0. So you plus 0. So you get 12 also. So the answer will be having as a 12. So binary code for 2 over here, and also binary 1. So the binary code for 12 is the answer. So next examples, all the other arithmetic operation can be derived from the add functions, which is, let's say you have the subsections, you have A minus B, or A plus minus B, or negative B. Same goes to the multiple and also divisions. So later on, let's say you did not fully understand on the example given from the module, I will give you extra notes on this logic operation, because you will use all these functions also in your lab, which is you will play around with all the logic gate, and you are required to build or to create your own arithmetic operation, let's say examples. So that's why you need to have the basic understanding. And if let's say because I think this notes quite simple, so I will add extra notes later on, and also video on this. So on the code conversion function, you can have over here a code is a set of bits arranged. You can see that it is a unique pattern and used to represent specific informations. So example is like ASCII operations or programs, and the use of code is to allow a faster and more efficient data processing. So this is the examples, extra examples of the code conversion functions. All of this is the symbols, how you get it basically from just a code to this, let's say, icon. So this is the table. If let's say you have this, what you're going to get to the output. So you have this symbols, and also how you type it in like this, so you get this. So this is under code conversion functions. You convert from the typing key in from the keyboard to the icon. Next is encode and also decode function. And the encode functions was given the examples in the picture here. You can have, let's say, example, you key in the 9, which is high in this pin only. So this is the encode IC, let's say over here, encode functions. So over here you have high in 9. So binary code for 9 used for storage and or computations. So you have another examples of the decode functions, which is, let's say you have the binary input. So for decode you have like this, let's say. So this is the 7 segment display. So later on you will notice that this function you have 1 and then 2, 3, 4, 5, 6, 7. Let's say like this. Is it 7, 1, 2? So how you going to make this to be as a number? Let's say over here 9. You need to draw like this, I think, for 9. 1, 2, 3, 4, 5. So how you going to get 9 is you need to have high in those pin number. So later on you will learn it. So like this one, the example, let's say I give you the example of 1. In your calculator keypad, you only press the number of 1, isn't it? Let's say I give you the example of 1. You press number 1, you will get like this at your 7 segment display for your calculator. So you get like this. So how this will happen is it mentions that over here the pin for these two will be high. So that's why you will get like this. So you have 1, 2, 3, 4, 5, 6, 7. So 7 segment display will display all of this. Let's say I give the example only, okay? This is the segment from 1 and 2. 1 and 2. So over here you will get 1 and 2 as high. So the rest is, let's say over here 3, 4, 5 until 7. All the input is 0. That's why if you press number 1, the rest, let's say over here you have like this. So this is the input 0, input 0, input 0, input 0 and 0, and these two input of this pin is 1 or high. That's why you will get 1 on your 7 segment display. There is no example yet on this, so I will give you more example also on the encode and decode, how it's going to look like, and how, let's say you press, we will learn also in the numbering of pin. I think in this video also I will put it into the pin number for your chip and etc. So let's move first on data selection functions for your marks and the marks multiplexer, which is over here. This is the short form for your multiplexer and the multiplexer. So over here you have one multiplexer over here, and this one is the marks. So what happened, let's say you give 3 input to your for your multiplexer. All is the signal form, and you will having the switches sequence control input inside the multiplexer. So data from A to D, data from B to E, data from C to F, you will move along and will be sent to the demultiplex. And data from A to D also over here, you can see basically it's move along. First you send the A, and then you will send the B, let's say, or and then after that followed by C, and it will move another way round, which is A to D and etc. So what is D is basically the output, you can see over here. So A will go to the output D, B will go to the output of E, and similar also over here. So what is going to look like after you multiplex and also after you demultiplex. This is just the basic examples. Later on you will learn more on the function and how it's happened. So over here you were given the problem. So I hope you can test it, which is you were given the problem and also the solution. Please try to screenshot this and try to understand these basic functions for your marks and the marks. Because if you didn't have the basic, and then it's very hard for you to move to the next level. So next is under data storage functions. Basically like the example that you have is on the flip-flop, register, and then semiconductor memories, magnetic or optical memories. This one is, I think, you always use, especially on your hard disk and then your DVD, and this one you use it every single day. And currently when you are looking to this video, you are playing around with your RAM and ROM. So over here, I think this is just a basic of what is a functions under data storage. So the examples on the flip-flop look like what gate is available inside the flip-flop, and then there is also examples on the memory itself, and then the flash memory, hard disk, and etc. Another one, the examples on the magnetic optical memories. So you have flip-flop, you have the register on your memory, and then you have semiconductor memory, of course, and then the magnetic and optical memories. So over here it is a counting functions. If you have the counter, you can count any sequence of that. For example, you need to count the occurrence at the input. So you were given the input pulse over here, so you key in it into the counter. So there is a parallel output lines will be for your output. Another objective is to initiate a controller after a certain count of period. So you will get the sequence of binary code that represent the number of input pulse count. So let's say 1 pulse, 2 pulse, 3 pulse, and so on. So you have over here binary code 1, binary code 2, until binary code 5. Depend on your input pulse also. So what example of system that use this counting functions is every day you look into your traffic light, and then washing machine, vending machine, Xerox machine, ATM machine, and etc. So we move on to another topic, which is on the fixed function integrated circuit, which is also fixed function IC. On this section, I will teach you how you're going to know on the numbering of your IC, because previously I mentioned about that. So over here you have the examples of laboratory prototyping in the picture. So the circuit is wired using DIP, which is dips, chips, and tested. So over here, if you zoom in, you can see the DIP DIP chips, dual inline package over here. And in this case, testing can be done by a computer connected to the system. So if you can allow to go to the lab currently, you will play around with all of this. But because of the COVID, we cannot go to the lab. So how the IC package look like? So DIP chips is basically look like this, and you have the you have basically the pin. So how you will count your pin is at the left above, it will started as 1. So if you have this kind of pin, let's say 1, 2, 3, 4, I give example only, okay? So your numbering will start on top of left of your chips. So it show over here, left and the upper side. How you going to know where is up and where is down? Basically I call it up because I want it to be look like this, upper. So when it up, so it will start from here. You can see also over here there is end view of each of the example of circuit. Later on, this one is just an example only. I want to show you on this numbering. Okay, I give you the example because there is notes over here, right? So how are you going to calculate the pin and identify its left top? So you need to place your chips like this, and there is a light hole over here called as notch, will be facing up. So from this left, beside your notch over here, you will mention it and identify it as 1, pin 1, and then followed by pin 2, pin 3, until pin, let's say over here you have pin 8, and it will move like this, and it continue pin 9, 10 until pin 16. So this is how the identification for DIP IC. Is it clear? Why you need this identification is later on when you do programming, you need to know where is it? You need to know which pin that you need to program. If you pin and program to wrong pin number, so your chip will be not function well. Same goes to the PLCC or LCCC pin. They have their own numbering system. So over here it's quite different from the normals, which is quite easier on this numbering method. But how it's look like over here? So there is over here like a notch over here also. So it will start, and you put it on top like this, and this is pin number 1. And then the move, how it's moved for your numbering system is it is a counterclockwise, which is not follow the clock sequence, but it's counter. So 1, 2, 3, 4, 5, and then it's move over here 6, 7, 8, 9, 10, 11, 12. You move like this, 14, 15, 16, until over here it's move along, and the last pin over here is 20. So this is how you identify your chips. So this is important. If you are a programmer, you will always do a program for your IC. So you need to know how to identify the pin number. Is it clear? So I go back first to this example. So this is the example for another chips for your small outline IC, and then plastic leaded chips carrier, and then leadless ceramics chips carrier LCC. These both two, which is this one, example of B. And as again, your identifications will move like this. And over here you have the IC and conventional through hole technology. This is just an example how it like. You can see whether you are a good soldier or not, because sometimes I also it is very hard to solve over here because quite small. So if let's say you have the notch over here also, your circuit will not function. Same goes to the surface mount PCB. Over here you need to program all. So how you need to know which is on the notifications identification of number pins. Next, you have the integrated circuits. So what happened inside your circuit is basically there is chips inside it. So this chip is very important, and it connected all to the pin. So you can see over here, and it cover it using a plastic case only. So this is all the pin which is connected to the chips inside your IC. So why we need packaging? Of course, to protect. The first one is your chips inside. It is very important to protect your chips, and having a pin system so that you can connect to the other circuit. So if you have the plastic case, you can have the notch or whatever you want to let's say create. You create it by your own. Let's say you want to create your own chips, so you will have the plastic case. Maybe you can just directly notify your buyer that this is the first pin. So depend on you how your creativity, but these two is why we need packaging. First man is on the protecting the IC or the chip circuit. So this is on the pin numbering and identifications, how you're going to justify your numbering. So this is just an example of your extra knowledge, how you're going to calculate it and identify. It will move like this first, and then you numbering it starting from here for your left. So over here 2, 3, 4, 5, 6, 7, and etc. until pin number 14. So this is the examples of chips 7400. And complexity on your classification for fixed function IC. This is just extra knowledge for you about the SSI, MSI, LSI, VLSI. There is subject called as VLSI as well, and ULSI. And this is integrated circuit technology. Just the examples on IC technology that available currently. This is the example of CMOS. This is quite famous if you are dealing with electronic. And this is last sections for your module 1. As I mentioned, I want to finish it by this week, and because actually I want to check, I think we already have our asynchronous class for this 2 week, just to check whether you open or play or not your video that I give. So what I'm going to do is I'm not going to write any tentative for this class. So this is the purpose for you, whether you are noticed about this or not. And if you watch this video, you will notice that you have an assignment. I give you the assignment for you to create a video. Only a simple one. You can just create a PowerPoint and then you just convert it into video. As long as you just occupy 1 hour just to create this section, only for the programmable logic device. So as in this slide, you have only few. Let's say over here, from here, sorry, it's accidentally closed. Where is it? Okay, starting from here, you have basically how many slides? 4 or 5 only. 1, 2, 3, 4, 5. 5 slides only. So in your creativity, maybe you can also refer to your others reference from your website, from your books. Also, you can do a reference and put it into your video as creative as you can, but please don't use your time long in just creating this video. Just nice as 1 hour only for this class. So let's say I give you the task over here. Insert. So the task is create video for sections on PLD only. So every one of you, I don't want to you do it in group, because if you need to do in group, if let's say you watch this video but your friend didn't watch, so you will help her in the or her, you will help her or his in notify that I give assignment. So just left and just don't mention in a group, in WhatsApp group or even the forums, don't mention anything about your assignment. Please just do it by your own, because you watch this video. I will take this as your attendance also, and I will bring this video as your course mark too. So I will take it maybe a few percent on these video creations just for your course mark. Extra course mark I will give you later on. So whoever didn't do it, so I just assume that you did not watch this video in your durations of your class. So please mention, I give all videos just for you to learn in your durations of class. Let's say your class is 8 until 10, so you just do it and watch your video in durations of 2 hours for your class. Or maybe your class is start at 11 to 1 p.m. So I will set it as long as 2 hours only. First 1 hour you watch the video, you have this video, and then you try to find another information from other resources, and then just 1 hour, another next 1 hour, you credit this assignment of video. So occupy 2 hours. So that's why for today class I will not attach any tentative. I just left it. I just want to inform you, please check your e-learning. I already upload the video. So that's all. So it's depend on you whether you want to play this video or not, and you want to watch it or not for your whole class. That's why I picked the last sections as the assignment. Is it okay? So starting from now, I give you time about 1 hour to complete this video, and after your class I will give the WhatsApp link. So I will give only about, let's say 15 minutes or maybe less, because if let's say 15 minutes, other student that did not watch this video will try to make it as soon as possible. So maybe just 5 minutes I will give you the link, and I will close the link after 5 minutes. So everyone already create the video can directly upload to the link I give and provide later on. And for the rest did not watch this video carefully, so you didn't get any extra mark, and your attendance will not be taken. Is it okay? Clear? Okay, thank you for your time for watching this video. I hope that you can just direct WhatsApp me and also asking me on the forum about your problem or difficulty in your study. It's very hard to study like this because this is online. Also it's quite boring, but what to do, we need to study, although it is MCO because of this COVID and etc. So I wish you best of luck just on creating the video. Thank you for watching.